Okay, this video is to go over the Ferris wheel problem from page 760. This will be the answer key for that problem. I apologize in advance if there are any background sounds during this video, as my roommates are home, but it should be all right. The first thing we're going to start with is just utilizing the visual aid that is already provided for us in the book. So we're going to just write that out one more time here. But we do know some of these points along the top and along the sides. We start here, and the time is equal to 0 seconds. And we know that the radius is 20 feet, and therefore the diameter is 40 feet. Okay, so this is what we know to start. We know this because the problem describes that the top of the Ferris wheel is 43 feet above the ground, and we know that Ferris wheels do not touch the ground, and it describes that this distance from the ground to the bottom of the Ferris wheel is 3 feet. So we know that the diameter is going to be 40 feet. Okay, so this is basically what we know so far. So getting into part A, where we want to sketch the graph, we can start with labeling our maximum and our minimum, which would be 3 feet and 43 feet. If you want to do the math at home, this would be 23 feet for the center axis of our sinusoidal graph. And we know from the problem, it describes that 1 full revolution takes 8 seconds. And so we know that from here to go all the way around is going to take 8 seconds. And thus we can know that we can basically divide this circle into 8 parts, which means it will take us 3 seconds to reach the top, 4 seconds to reach back to the bottom, and 1 more second to reach back where we started. That's a total of 8 seconds. So it takes us 3 seconds to get to the top. So we can write that in as 3 seconds to reach the top of 43 feet. Okay. Then we know that it takes 8 seconds to get around, so we can add 8 to 3, and we know that our period is going to be 8 seconds by the time we would reach the top again. And so we can write 3 to 11. Again, we can do the math at home if we want to label these further points, but halfway in between you would reach your minimum, and halfway between those you would be on the center axes. We can now connect the dots, and it would continue to go like so, but this is all we need. Okay, so that's the graph. Just some notes to write down is that the amplitude would be 20 feet, in fact. The period is 8, which then we can use to find our exact B value that we would use to plug into the exact equation, which we will see is going to be handy for the next part. And we know that the vertical shift is equal to 23 feet, and the horizontal shift is going to be 3 to the right. Okay, part B, this is asking us what is the lowest that the Ferris wheel goes. The lowest that it will go is 3 feet, because Ferris wheels do not touch the ground. So let's write that out. Okay, part C asks us to write the particular equation of this. And so we can start with our y equals because we start at a high point and go down and end at a high point, we can use our cosine function, and so we can write that in. We know the amplitude is going to be 20, so we can write 20 cosine, and then our period is 8, but our actual b value needs to be 2 pi over our period, so we'll actually write in pi fourths for our b value in this. We're going to use t for time instead of x in this situation. And then we're going to write in the horizontal shift. That will be -3 because it's going to the right and not +3. And then because we are going up 23 feet for the vertical shift, we can write +23. And this would be our particular equation for this problem. And then lastly is part D. This is asking us to find the exact values of the height at certain times. And so all we need to do is plug in those times for t. So for example, number 1 is asking at t equals 6, or time is equal to 6 seconds. So we can simply plug in 6 for t, and so we would write it like so. And then we can easily plug this into our calculator and solve to find the answer. When you plug it into your calculator, it should look something like this here that is highlighted. You'd write 20 cosine 6 pi divided by 4 minus 3 plus 23, and you would get an answer of 20.177 approximately. Something to note is that the answer key is going to give you a different answer than that. This is, again, because of the trickiness with they're distributing and not distributing as they should in the answer key. So we will know that this is going to be the actual value, and we can just write it like so. I will not proceed with the rest of these. You can do these on your own, but all you have to do is plug in for t and solve.